Okay, in this recording, we're looking at some additional information from section 9.5 that will be helpful for you when doing your homework. Now, we were looking at the domain, the input, and the range, the output from functions. And when you're looking at a graph, whether or not the graph represents a function, you still have those input x values and those output y values. So you still have a domain and range. And so there's a couple different things that are going to appear for you in describing those domain and range values. So we're looking at what's called interval notation to be able to write the domain and range. And so you might want to copy this chart down. Our first option is the braces. Notice the braces here are the squiggly lines that represent a set. We saw that in our set notation. And so when we have those, we have just specific values, A or A, B, C, things where there's only one or a handful of specific values for either the x's, the domain, or the y's, the range. And again, we'll look at some graphs, and so it'll be a little bit more understandable with that. And then you'll have a choice where you will have a starting and a stopping point for the graph. And so you have a bracket for your starting and stopping points, A and B. And so they're specific and they're exact. That's why you have a bracket. And whereas the braces here list A, comma, B, comma, and more if need be, they're specific. In the braces or the bracket where it's straight like this, it's from the first point to the end point and everything in between. Now sometimes you'll only have one endpoint, which are the next two examples, and so we'll either start and then go on forever in the positive direction. And notice the specific starting point has that bracket. The infinity has a parenthesis. What's the difference is that A is a specific exact number, and infinity, you cannot tell me where infinity starts or stops. So that's why it's more ambiguous and it's denoted with a parenthesis. And sometimes it'll come from negative infinity and stop at a specific point. So then your infinity comes first with a negative infinity and then your specific stopping point. So again, notice one side has parenthesis and then the other side has a bracket. Or you can have all real numbers, which would be negative infinity to positive infinity. And again, both sides have the parentheses because of the infinity sign. I put a note here. Sometimes Hawks will already have the grouping symbols for the answer given. So, for example, if you're listing a specific set of numbers, they might already have those symbols in front, and then you're just entering your values separated by commas in between. And you'll notice that if you try and hit that button, the computer will ding at you and tell you it looks like you're trying to enter a symbol that's not needed. But when you're looking at the brackets versus the parentheses, you'll be expected to use that. And the different combinations are available under your math tool button. Same thing with your infinity sign. So here's an example of a graph that you will see from your homework. And we can see that this is not a function, because if we do the vertical line test, there's many places where we're crossing more than one value. So no, it is not. And when we look at the domain, we're looking at left or right, because that is our x values. And so our smallest x value is here at 0. Our largest x value is right here at 8. And so since it's a specific starting and stopping point, we'll use our brackets. So smaller number 0, comma, largest number 8. So again, all numbers in between are included. So that's why we have the bracket. Now our range is our y value, so it's our lowest to highest. Our lowest value is here, which is at -3. Our highest value is up here at 5. And so our range, again, we'll have brackets, and we're going from -3 to +5. Now let's look at a different example. Is this a function? Well, again, vertical line test, if we go through here, 1, 2, 3 places is where it crosses. That's x equals 3. And so no, it is not a function. When we look at our domain, our x values, the furthest we come over here, notice it has an arrow, so it keeps going to -infinity. Our furthest right has this elbow, but if you look, it doesn't stop there because up here we have an arrow. So this is eventually going to go past that 9 and keep going. And so our domain is our -infinity to +infinity. And our range, lowest is the arrow, highest is the arrow, so it's also going to be -infinity to +infinity. Now, just so you know, if it's going to level off somewhere, it's going to be very distinct. You're going to know that. So let's say, for example, we have another sharp turn down here at x equals 2, and it starts heading south. Like that. It's going to be very clear that it's following that x equals 2 line down, and it's not going to shift. And so you'll be able to tell when you're doing your homework whether or not it's going to continue on forever or it's stopping and just continuing on at the same value for the rest of it. Here's another example. This time it is a function, because if we did the vertical line test and came through at any point on this graph, we would only cross it once. This is a parabola shaped, and the domain are x values. So again, when we go furthest left and right, we get arrows on either case where it's going up and out forever. And so there's going to keep going out and out from -infinity to +infinity. Now our range, on the other hand, when we go to the bottom, that's where we have our turning point of our graph, which is called the vertex, and that's at y equals 1. But then we go up higher, it's going to go on to infinity. So that's where we have our brackets, which in this case it's starting at -1, and we're going off into infinity. Here we have a horizontal line, and so this one actually is the graph of y equals -3. And so is it a function? Yes, because no matter where we draw a vertical line, we're going to only cut through that line one time, our graph. So yes, it is a function. Our domain, our possible x values. Notice all the way to the left is an arrow, all the way to the right is an arrow. So that's our -infinity to +infinity. But when we go to do our range, there's only one y value that's ever going to be used, and that's -3. And so we're going to use our braces, since it's one value, and put our -3 in there. We're just listing one number. Okay. And so the last one I want to show you is the set of points. And is it a function? Well, if we check this point here, it works, but not here or here. So vertical line test doesn't work for all points. So no, it is not a function because there's a couple points that have the same x value. And so for our domain and our range, we're just listing the specific. So again, we have to use the braces to show that it's not from one point all the way to the next and everything in between. It's these specific values only. So our first x value on the left is -5. And then we keep going to the right until we hit 2 at 4. So we only list 4 once, even though there's 2 points. And then we have 2 more at x equals 6. And then we have one final point at x equals 7. So our domain is just those 4 specific points. Now our range, if we look at our y values, we're bottom first down here at -9. Then we keep going up and we're at -3 for our next point. Then if we keep going up, we have 1 point at 0. Our next point at y equals 2. And then if we keep going up, we have 1 at 5. And our final point is at 9. And so we have several y values for our range. Okay, I hope this helps you to be able to do your homework. If you have any questions while doing it, again, don't hesitate to send me an email, take a screenshot for me so I can see what you're working on, and I'll be more than happy to get back with you. Until next time.